be a solution to this problem.
When are you gonna get your TV?
Yeah, I want my TV. Not TV. I want the giant interactive screen. Giant touch screen.
You could do a petition to get your screen.
You can just go on strike.
So is there a teacher here who has a giant touch screen? There's the middle schools have some.
There's some of those touch screens are here.
Really?
So like,
They're really big touch screens?
not like the giant ones, but like the ones that take up like half the whiteboard.
Yeah, I want a really big one. Because they showed us one and they said, hey, you want one of these? And I said, yes. And then they just
Never gave you
said, they just didn't give me one.
Okay.
All right. So all you really had to say on number 1A and 1B are, you could say it two different ways. If you make the car heavier, you add more mass to it, but you use the same force, it's going to go slower. So you could say there's less acceleration. Just using Newton's second law, writing the formula out, and changing the size of the letters in it to represent the size of the forces and accelerations and stuff, it looks like this. So here's the force. This is supposed to be the same size force. Tried to get my F the same. If I make the M bigger, then the A has to be smaller. So these two, if one goes up, one has to go down. And so for 1A, you just say it slows down. And then for 1B, Macy, you should hurry back just so you can see the rest of these and know if you want to retake it. If the car's mass has been kept the same, but it's accelerating more slowly, what must have happened? So I didn't have that part. I just redid this, and I kept the mass the same size. I kept this M the same size as this, but then I made the acceleration really small. So if you multiply these two numbers together, but you make this one littler, then the product, that is going to be small, so the force is smaller. And this is kind of common sense. I think most of you would figure that out, even if you didn't have Newton's second law to help you. Number two, most of the answers here are just what I was looking for. I've run into at least one that didn't really talk about the action and reaction forces. I want to know, you've got to describe two forces, the action force and the reaction force. I don't really care which is which, but there are two forces and they're equal and opposite. So as I wrote up on the board, here's my first object. This is the student, and this is the force. It's a pull. And this is the second object, the rope, and this is the direction. So if this is the rope and you have a student here hanging from the rope trying to climb it, so this force would represent the force the student's applying to the rope. And then the equal and opposite force would be the rope pulls the student up. So those are the things I was looking for. With the baseball player throwing a baseball, here's the baseball. I'm just going to do a really bad picture of a hand. There's the hand. And so the hand pushes the ball to the left, and if the hand pushes the ball to the left, then the ball has to push the hand back to the right. So player pushes the baseball left, ball pushes the player right. Now we get into the trickier ones, the problems. So there's this truck, and you're given some forces. You're supposed to figure out the motor force. You've got the mass. You've got the acceleration. You've got friction. So I'm using F equals ma here, and you could use it in this form right there, but what I'm trying to find is the net force. So I want the net force. That's not what I'm being asked for, but ultimately it's going to help me. So the net force is the mass, 1,000 times the acceleration, which is positive 3, and that gives me, I'll put a little positive, 3,000 newtons. So that's one way to get the net force. The other way to get the net force is to add up all the forces, and there are two. So motor force and friction. And as I was just saying a little while ago, this is not just, you don't just add these numbers, but you take into account the direction. So you take into account the fact that they're vectors. This is the vector sum. So this force is what, positive or negative? Positive. This force is negative because it's to the left. So when I write this equation here, I write the net force is 3,000. I already figured that out up here. I figured it out using Newton's second law. The net force equals the motor force minus 500 newtons, because the motor force is positive and that's negative. So now I've got this really easy equation I can solve. 3,000 equals something minus 500. So add this to both sides, and the motor force has to be 3,500. And on this quiz, if you don't have units, I'm not going to take off points, but on the test I will, so you should really practice that. So once you've got this answer, you could check it out. You could say, okay, 3,500, I'll put that here. 3,500 to the right, minus 500 to the left gives me 3,000. That's the net force. And the mass, 1,000 times 3 is 3,000, so it all checks out. This one, you're given, there's a force to the right and a force to the left and the acceleration, and you're looking for mass. So I'm just going to use all my formulas and see what I can do. One formula that I can use is this. This is the net force, which is the vector sum. To get the net force, all I have to do is add up all the forces, and there are just two. There's 30 and there's 86, but I don't want to do 30 plus 86 is 116. Why not? That's not the net force. What's wrong with adding these two together and getting 116? Yeah, this is negative. So this is positive 30, and this is negative 86. So if I add these forces up, I get 30 minus 86, which is a net force of 56 to the left. So the net force is negative 56. Now that I have that net force, I could go looking for another formula to find some stuff, and this is the one. So I have the net force, I have the acceleration, and I need to find the mass. So a word about this acceleration. Is it positive or negative? Negative. So I'm going to write, I'm going to use this triangle to get the formula for m. So that is m equals the net force over the acceleration. And the net force is negative 56. And the acceleration is negative 7. So I don't know, Tucker, if this is what you were thinking about, but Tucker wasn't even in here. You might want to watch the video. So this is why mass does end up being positive. If you just divided negative 56 by positive 7, you'd think, hey, you can't have a negative mass, but the acceleration is negative 7 and the net force is negative 56. So that's how I get that. Number 5, the easiest thing in any of these problems is weight. If you look at the weight formula and you happen to have everything you need, just calculate the weight right ahead. Weight is mg. So the triangle version of this looks like this, but if all you're doing is solving for weight, it's just mass times g. So 3 times 10 is 30. Done.
You said that you divided, like you said acceleration can't be negative, right?
No. Mass can't be negative.
Mass can't be negative.
Acceleration can definitely be negative.
Well, if it's going down, then would it not be negative?
If this is going down, it is negative. So this is negative acceleration. And there are two ways to show negative acceleration. There's 3.3 meters per second squared with a down arrow, or there's negative 3.3 meters per second squared. This is how I would show it mathematically in a formula, and this is how I like to put it in diagrams. It's confusing to write negative 3.3 and put an arrow down, because that kind of looks like maybe it's up. Crow?
You might have said this, but how many points do we get taken off if we put a negative where there's 1 or 2?
So if you had all this right, but you just had, you didn't show that this was a downward acceleration, just a half a point. This one's worth 4 points. This one is worth 2 points. So this is 4 because it's really got like 2 problem parts in it. This is 2 because it's a problem and you're just looking for one thing. This is 2 because it's a problem and you're looking for one thing. So just a half a point if you have the wrong direction. And maybe even less, depending on circumstances. But let me continue with this. So my first step was I could use this formula, so I did. So I got the weight. And now that I have the weight, I've got both of the forces. I've got 20 and I've got not 30, I've got negative 30. So my next step is just to add up the forces and get the net force. So 20 minus 30 is negative 10. And then my third step, if I'm looking for this acceleration, then I need the acceleration formula. And for that, I can use net force equals ma, but cover up the a, and it's net force over mass. So if I write that, the net force is negative 10 newtons, the mass is 3, negative 10 over 3 is negative 3.3, which means 3.3 downward. So the retake for this quiz will have the same kind of format. It's going to have some pretty easy questions. I think most people got these right. And then some of these, and then 3 force problems. The last one you'll have